Hey, AP Chemsters, this is Mrs. Valerie bringing you Blankwalle 4.9 Part 2. This is a little bit of a longer section than most of them are, and it's also brand new to you, so that's maybe why it's a little bit longer. Part 2 is now the crux of the section. It's not enough to know just the oxidation numbers. It's not enough to know if it is a redox reaction or not. What you ultimately need to know is how to balance redox reactions. So here is a second list of rules, and I would commit them to memory, and I mean that. The rules are: write the separate reduction oxidation reactions, and then for each half reaction, do it in this order. Balance your elements except for your hydrogen and your oxygen. Then balance your oxygen using water, and then balance the hydrogens using H+, and finally balance the charge using electrons. Once you've done that, you need to multiply by integer to equalize the electron count. All right, so for every reaction that you lose electrons, that's your oxidation, you have to gain the same number of electrons. Okay, you can never have an excess or a loss, net loss of electrons, okay? Then you have to add them together, and if you are in basic conditions, you have to add hydroxide, and then always in number 6, check that your elements and charges are balanced, okay? So the rest of this video is practicing this, and I'm gonna ask you, and I mean it, to go back to these 6 rules and follow them in order, all right? May I say right now, you should do a couple things, and maybe jot it down over on this right here, okay? I didn't type it up, but you can copy this down from what I'm going to say. The places that people make the most mistakes are they drop their charges or they forget to multiply throughout, okay? So do not drop your charges. Be very, very aware of all the charges you are writing down and don't lose any of them, okay? And folks, I've been doing this a long time, and that's a very, very common mistake, okay? And it's going to cause you a lot of grief if you do that, all right? Because you have to go back and find your mistake, okay? So let's look at problem number 38. Well, what was our first rule? Let's kind of scroll back up, right? Separate reduction, oxidation reactions. Well, how do I go about doing that? I need to know the oxidation numbers. So let's kind of find the easy ones. I know that iron charge 2+ has an oxidation number of +2. Iron with a charge of 3+ has a charge of +3. Manganese, with a charge of +2 has an oxidation number of 2+. But now let's look at permanganate. I know that oxygen is going to be -2. So go ahead and do that math. What times 4 times -2 equals -1? Did you get +7? Okay, hopefully you did. And so now we need to look at what is being oxidized, what is being reduced. So what oxidation number went up? I'm seeing manganese went from +7 to +2. And I say iron went from +2 to +3. So I think your oxidation is this right here, okay? So let's scroll up and see what we do next. Balance the elements except hydrogen and oxygen. Folks, the irons, there's 1 iron here and 1 iron here. It's already balanced. There is no hydrogen and oxygens. So then I can go and balance the charges using electrons. So what I like to ask is, what is the more positive side? It's the iron with the 3+, isn't it? So I need to add my electrons on the most positive side, and so there it is. Now, does that make sense? What is oxidation? Lose electrons, oxidation. Lose means the electrons are on the product side. The charges make sense, okay? And that's all we can do right now for the oxidation. Let's take a look at reduction. So the manganese went from +7 to +2. So that's what's being reduced. All right, let's look at our rules. Balance all the elements except hydrogen and oxygen. So my manganese is just 1 here and 1 there. All right, that was easy. Now what? Balance the oxygens using water. All right, so now I need to do that. I have 4 oxygens here and none here. So I need to add water, and the question is, how much water do I need to add? If I have 4 and none, I need to add 4 waters. Why? Because if I carry that 4 throughout, there's my 4 oxygens. But oh no, what did I just add? I just added some hydrogens to this mix, all right? So what does it say I need to do? Balance the hydrogens using H+. Oh, I can do that. All right, so here is my H+. And now how many hydrogens are right here? Looks like there's 8 of them, so I can put an 8 here. And so now what? Oops. If necessary, no, wrong one. Balance the charge using electrons. All right, so where is my most positive side? Let's add up my charges here. So it's -1 plus 8. Well, what's -1 plus 8? I think that's, isn't that -7? What's my overall charge here? +2. So that's what I did right here. I'm trying to figure out how many electrons I need. So -1 plus 8, this is my more positive side, so I'm going to add my electrons right here. And that's equal to my right-hand side, -2. Well, do the math. So this is a +7, plus how many electrons will equal +2? I think I need 5 negative charges. So I'm going to put my 5 electrons right here. Okay. So now I am ready. Okay, I've done all of this for each half reaction. Now it says, if necessary, I'm at number 3, multiply the integer to equalize the electron count. So how many electrons are lost? 1. How many electrons are gained? 5. I cannot lose 1 and gain 5. I have to gain and lose the same number. So what am I going to do here? I'm going to multiply this by what number? I'm going to multiply it by 5. Okay. Why? So that I will lose 5 electrons and I'm gaining 5 electrons. All right. And they're going to cancel each other out. So now I am ready to add the half reactions. I'm doing step number 4 right now. So I'm going to add up the half reactions. So don't forget to start multiplying here. So I have 5 iron, 2 pluses. My electrons cancel out. I have 1 permanganate. I have 8 hydrogens. Those are all my reactants. Then I have an arrow. I have, don't forget, 5 iron, 3 pluses. 1 manganese, I can say it, ion, whatever. And then we have 4 waters, okay? And so there it is. So again, I have 5 iron, 2 pluses. My electrons canceled out. 1 permanganate, 8 hydrogens. Those are all my reactants. So everything on the left-hand arrows goes together. Next, I have 5, don't forget to multiply, 5 iron, 3 pluses. That's what the other thing that people will forget to do, is to carry that 5 throughout. I have 1 manganese, I got it right, 2 plus ion, and I got 4 waters. So what's my last thing to do? It's not in basic, we're good. It says an acid. I don't have to do number 5. I'll show you that in a little bit. It says check that the elements and charges are balanced. So I have 5 irons, 5 irons, 1 manganese, 1 manganese, 4 oxygens, multiply there, 4 oxygens, 8 hydrogens, 8 hydrogens. Now let's do my charges. I have plus 10, minus 1. What's 10 minus 1? I believe it's 9. What's 9 plus 8 is 17 plus charges. So my left-hand side is 17 plus charges. Over here, I have 15 plus 2 is 17. Now, why do I have so many plus charges? I have spectator ions in here. Maybe I have some, I don't know, chlorines hanging around. All right, maybe I have some nitrates hanging around. There's spectator ions. They don't count in my equation here, but they would actually equal out the charge in the long run. So maybe I have 17 nitrates on both sides. It doesn't make any difference. Everything is balanced. Everything in my net on an equation, in a sense, I have my atoms are balanced and my charges are balanced. Okay, let's go to the next page and let's try another one. So problem number 39, silver is sometimes found in nature as large nuggets. Often it is found mixed with other metals and their ores. An aqueous solution containing the cyanide ion is often used to extract the silver using the following reaction that occurs in a basic solution. All right, now notice I highlighted basic, so we have to do that extra step. So what is the first step we need to do? We need to write down the oxidation numbers of everything, all right? So I'll just kind of help you out. Use the nitrogen as a -3 because it'd be a nitride in a sense, and then you can figure out the carbon from there. Okay, so if nitrogen is -3, go ahead and figure out the rest of them. Go ahead and pause this and do the oxidation numbers of everything. Okay, hopefully you found it. If you paused it, you had a little time to figure it out. So let's do this. This is what I came up with. So silver is an element all by itself, so it is 0. If nitrogen's -3, carbon must be +2. Because when I add these two numbers together, you get your -1. Oxygen is in its elemental form, it's 0. Silver is in the silver cyanide ion. Remember, if each cyanide is -1, all right, and there's an overall charge of -1, all right, silver must be +1. So again, you could do your equation where silver plus 2 cyanides equals -1. Cyanide is -1. So we have silver plus 2 -1s equals -1. Silver has to be +1. Okay, so what got oxidized? All right, what went up? Hopefully you figured out the silver got oxidized. All right, it went from 0 to +1. Okay, so here's my 0 and silver went to +1. There's my oxidation. Well, what was rule number 1 now? All right, balance or identify your oxidation reduction. Did that. Balance your elements besides hydrogen and oxygen. Well, my silvers are balanced, but my cyanides are not. So how many cyanides are on this side? 2. So I need 2 cyanides on this side. Okay. And so now what? I need an electron, don't I? So I have 2 negative charges on this side. See that? And I have only 1 negative charge on this side. Where is my more positive side? Well, how about this? Which is my less negative side? It's over here. By how many electrons or by how many negative charges? Only by 1. So I'm going to have 1 electron right here. So look at my charges. I have 2 negatives here. I have 1 negative and 1 negative here. So my oxidation is now balanced. Okay. So what about my my reduction? Well, that's kind of weird. Cyanide and nitrogen, or carbon and nitrogen didn't change, but oxygen's here. But what else is happening here? It's in a basic solution. What's in a solution? Solute and solvent. What solvent do you think is in this solution? I bet it's water. I bet it is. It's a solution, so it's going to have some water. And if you recall, oxygen is 0, oxygen is -2. Yes, it got reduced. Okay, so let's go and see what we do next. Go back on this page. Balance the elements except hydrogen and oxygen. I don't have anything besides oxygens and hydrogens, all right? So balance the oxygens using water. Okay, let's do that. I guess I already did that because I put a 2 here, all right? So I have 2 oxygens here, and I have 2 oxygens here. All right, what's my next drill? Let me see. All right, balance H's using H+. All right, I need to do that, don't I? All right, so I need some H pluses. I need them on this side, okay? Because I have H's here, I don't have any H's here. Well, how many H's do I have? 2 times 2 is, everyone, you can say it, 4. That's right, very good. All right, and then what? I need to balance my charges. My net charge here is +4. My net charge over here is 0. There isn't any charge. So where's my more positive side? This side. So I need to put 4 electrons here. Okay, you can put them over here if you want. I don't care. Or here, I can do it like this. All right, I'm sure some people care. All right, so here we go. So what does this mean? I'm ready to add my two half reactions together. But look at your electrons. I have one electron here. I'm losing one electron. I'm gaining four. I can't do that. If you ever figure out a way to do that, you'll get a Nobel Prize, I'm sure. Okay? Win $1 million, shake the King of Sweden's hand, and just remember me in your speech. Okay? But right now, for our understanding of our world, you can't lose one electron and gain four. Okay? You have to have the same number. So we need to multiply this by what number? Well, hopefully you realize you have to multiply it by 4. Why 4? So I lose 4 and I gain 4. So what do I do? Oops, what do I do next? I have to add everything together. Okay, so multiply 4. I have 4 silvers. And what's 4 times 2? 8 cyanides plus 1 oxygen plus 4 hydrogens. Those are all on my reactant side. Then I'm going to add on my product side 4 of the silver cyanide ion. My electrons canceled out, and then I have 2 waters. Okay, so how does that look so far? If I were you at this point, I'd check my work. Make sure you haven't made a boo-boo at this point. So I have 4 silvers, 8 cyanides. Well, 4 times 2 is 8 cyanides. 2 oxygens. Here's my 2 oxygens. 4 hydrogens. What about my charges? All right, I have -8 here and a +4 here to get -4. I have 4 times -1, which is -4. All right, it looks like I'm about done, except I'm not. It says it's in a basic solution. All right, you're in a basic solution. So what do? If in basic conditions, add hydroxide, okay, which it is. I have to add hydroxide to both sides to make it basic. Well, how do I know how much hydroxide to add? Well, what is it right now? Is this an acid or is this neutral? What is it written as right now? It's an acid right here. Here's my acid. So I have 4 H pluses. What's going to neutralize 4 H pluses, folks? 4 hydroxides. So you're going to add 4 hydroxides to both sides, all right? And watch what happens, oops, when you do that. Okay. This remains the same. This remains the same. This remains the same. What happens right here? 4 H pluses plus 4 OH minuses makes 4 waters. I have this plus my 4 hydroxides. Now, what can I do at this point? All right, I can, let me switch over real quick. I can cancel out like terms, all right? I have 2 waters here. So if I subtract 2 waters here, -2, how many waters am I left with? Well, hopefully you figured out you have 2 waters left over, okay? So this is my final answer. So that remains the same, that remains the same, that remains the same. 4 minus 2 is 2. Here's this. I cancel this out because it's on both terms, all right? And then here's my 4OH. What might you do again? You better check it. That's always your last step. Always your last step is to check it. So I have 4 silvers, 8 cyanides. 4 times 2 is 8 cyanides. 2 plus 2 is 4 oxygens, 4 hydrogens, 4 hydrogens. All right, my elements are balanced. So what about my charge? I have -8 on this side, and therefore I have -4 here and -4 here, so I have a -8. So what does that mean? I have a -8 on both sides. I spectator ions. That's fine. I have some sodiums floating around. That's awesome. All right. But this is my net ionic equation, and that's what works. Okay, we're there. So let's look at problem number 40. Okay, so it says potassium dichromate is a bright orange compound that can be reduced to blue-violet solution of chromium 3+ ions. Under certain conditions, potassium dichromate reacts with ethyl alcohol as follows. Okay, let's set this up. All right, let's see what happens here. Well, first things first, let's go ahead and check the oxidation numbers of the things that you know about. So I do know, here we go. I know some of these things. I can do this pretty easily right here. All right, hydrogen is 1. Hopefully you remember that we've already done this one. That was on the part 1. We already know what the chromium is here. It's +6. Oxygen's -2. Hydrogen's +1. Oxygen is -2. Oops, that should be a -1 for that hydrogen. I don't know why that's stuck here. Let me put this back here. All right, so the problem is, what's carbon? Well, I don't know what carbon is. So let's find out what carbon is. All right, so I'm going to start this up again. So carbon plus 6 hydrogens plus oxygen equals 0. I have +1 for the hydrogens, -2 plus 4 total equals 0. So carbon is a -4. So now I know what carbon is. I'll put it over here. Okay, so now what? Well, what's chromium? Chromium is a +3. Here's my water again, +1 -2. Well, if carbon, or if oxygen is -2, and then carbon must be +4. Okay. Whew, that took a little bit. So now what? I need to come up with the oxidation half reaction. What went up? Look at your numbers. What went up? Ooh, I think it was carbon. -4 to +4. It did. It went up. So that's my oxidation half reaction. What is the first rule? Go back 2 pages. What's the first rule? Balance all your elements except for hydrogen and oxygen first. So are my carbons balanced? Yes or no? No, Mrs. Vandalay, you're right. So I need to put a 2 here to balance it. That's so important. Oh, that's so important. All right, now balance your oxygens. How many oxygens do I have right here? 1. How many do I have here? 4. So how many waters do I have to add? I have to add 3 waters. Okay, now what? I have to balance my hydrogens. Well, how many hydrogens are here? I have 6 hydrogens, and I have 6 hydrogens. Well, 6 plus 6? 12. You're right. Okay. And now what? I need to balance my electrons. How do I do that? Well, I have no charges on here. I have +12 here. So I need how many electrons to balance out a +12? I need 12 negative electrons. This is now balanced in elements and in charge. So what got reduced, everyone? Well, chromium is a +6, chromium is a +3. Chromium got reduced. So what's the first thing I have to do? Balance the non-hydrogens and oxygens. So I'm going to put a 2, whoops, I'm going to put a 2 right here. Okay, notice that my chromiums are now balanced. I can now balance my oxygens. If I have 7 oxygens here, how many waters do I put? I put 7 waters. Now what's goofed up? My hydrogens are goofed up. So I need to put 14 hydrogens right here. So I'll do that. So I'm left now with balancing my electrons. I have, what's my net charge on this side? What's -2 plus 14? I believe it's 12, isn't it? Plus 12. And I have +6 on this side. So how many electrons do I need? I need 6 electrons. Okay. Think about what I've just done, and hopefully it makes sense to you each step. It's the same steps. I keep going back to that list of rules. Okay. So now I'm on the rule of I have to multiply one of these if necessary, and it is, by an integer so that my electrons cancel out. Here I am losing 12 electrons. Here I'm gaining 6 electrons. I can't do that. Again, you'll get a Nobel Prize if you do that. So I need to multiply this by what? By 2. Whoopsies. So now what does that do for me? It means I have 12 electrons being gained. I have 12 electrons being lost. That works out nice, okay? So now I'm ready to add my 2 half reactions, okay? So everything on this side, okay? So look what I've done. Follow along with me. I have 3 waters, 3 waters, 1 ethanol, 1 ethanol. Don't forget to multiply everything by 2 in the bottom. So my electrons cancel out, so I have 2 dichromates, and 2 times 14 is 28. So those are everything on my reactant side. Now I need everything on my product side. So I have 2 carbon dioxides, yes. 12 hydrogens, yes. My electrons canceled out on purpose. I'm good. Don't forget to distribute. So 2 times 2 is 4 chromium ions, chromium plus 3. And then 2 times 7 is 14 waters. Now, look at this. Is there anything that you can do at this point? And the answer is yes. You can cross some things out. Here I have 3 waters. Here I have 14 waters. So how many do I have left? 11, right? Is there anything else I can cancel out? Yes, I have 12 here. So I can subtract 12 and get, I believe it's 16. All right, so now what? Let's see what I get. Okay, so here is my ethanol. Here's my 2 dichromates. Here's my 16 hydrogens. 2 carbon dioxides. I canceled out my 12. So I have 4 chromium ions, and now I have 11 waters. Folks, what is the last thing I have to do? And it's check my work. All right, so I have 2 carbons, 2 carbons. I have 6 hydrogens plus 16 makes 22 hydrogens. I have 11 times 2 is 22 hydrogens. So good. I have 1 oxygen. I have 14 oxygens, so it adds up to 15 oxygens, right? So here I have 4 oxygens and 11 oxygens adds up to 15. So far, so good. I have 4 chromiums, 4 chromiums. I think that's everything, isn't it? So now check my charges. Well, what's 2 times -2? It's -4. So -4 plus 16 is positive 12. Over here I have nothing, positive 12, nothing, so even the charges cancel out. So folks, what if you forgot to multiply this by 2? Guess what? Everything's going to be wrong. Okay, so that is why it's so important that you follow the rules and you check your work. I did one more with you. All right, so let's go to the next page and we'll do this one together again. And I'll have you do the rest of them on your own, okay? All right, so let's go. We're supposed to balance this equation using the half reaction method. All right, so what's my first step always? My first step is to figure out what's being oxidized, what's being reduced. So you need your oxidation numbers. So copper should be easy. It's an element, it's a solid, it's 0. So what's nitrogen going to be? Go back and think about what would be the oxidation number of nitrogen. If you need to write that equation down, go for it. So do that right now. All right, hopefully you figured out it was a +5, all right, because oxygen is -2, so 3 of those is -6, so nitrogen -6 equals -1, nitrogen's +5. Copper is its charge, if oxygen's -2, nitrogen's +2. So what went up? What was being oxidized? Look at your numbers carefully. It went from 0 to +2, the copper did. Okay, so here's my first half reaction. What's my first step? Balance your elements. Guess what? Copper is already balanced. Is there any hydrogens or oxygens? No. All right, so don't worry about those. Now balance your charges. Which side is more positive? The Cu2 plus is. Oops, so that gets the +2 electrons, and I'm balanced. Okay, I'm good right now. So what's being reduced? Well, what happened to nitrogen? It went from +5 to +2. So my nitrogens did, so that's being reduced. All right, are my nitrogens balanced? Yes. Are my oxygens balanced? No. I have 3 here, I have 1 here. So how many waters should I add? Everyone, ready? I need 2, right? So I have a total of how many oxygens on this side? I have 3, right? Oh no, what happened? My hydrogens are messed up, right? So I have no hydrogens over here. I have 4 hydrogens over here. So how many H pluses should I add? 4, okay? And now what's left? I need to balance my charges. So if you look, I have a -1 plus 4, which gives me +3. Here I have 0 and 0, which gives me 0. So which is my more positive side? It's over here. So I have to add 3 electrons. And once again, it should always work out. Oxidation is lose. Notice how I always have my electrons on the right-hand side, if I did it right. Reduction is gain, grr, all right? So we're gonna talk like a pirate, grr. All right, gain electrons. Notice how I always have the electrons on the left-hand side, the reactant side when I do this, all right? If that's not what you're getting, you've made a boo-boo, haven't you? So oxidation should always have them over here. Reduction should always have the electrons over here. But we have a little problem now, don't we? What's my problem? Well, what do I have to do to both equations? What number does both 2 and 3 go into? It goes into 6. I got to get 6 electrons to gain and to lose. So I need to put a 3 here. And what do I need to put over here? I need to put a 2. So this is a doubly important thing to make sure you keep track of everything. All right. So we're going to distribute. All right. So I get 3 coppers. Oops, I left out, this should be an arrow. And then my electrons canceled out. So I have 2 nitrates and 2 times 4 is 8 hydrogens. I have 3 Cu2 pluses, my electrons canceled out. I have 2 NOs and 4 H2Os. So what should I do? I should now always make sure this works. So I have 3 coppers, 3 coppers, 2 nitrogens, 2 nitrogens, 6 oxygens. I got 2 here and 4 here for 6. I have 8 hydrogens. I have 8 hydrogens. Good. Check my charges. I have a -2 plus 8 is +6. I have +6 and 0, 0. It works. What I would like you to do now is go ahead and try problem 42 and 43. All right. This one's in base. So go back and see how we did our base. And this one's in acid. All right, so you have fewer steps in problem 43. But try these, all right? We'll go over them first thing on the next day, all right? And then see how you do, okay? So hopefully this helps. Don't wait to be great. And don't forget my helpful hints that if you made a mistake, go back and make sure you never drop the charge and make sure you distributed properly, okay? So take care. We'll see you next time. Bye-bye.